Alright, here we go with video on 2.1, which is solving equations. Now, we went through these notes in class, so if you're watching this video, I'm assuming that you either were absent or you're just going back to review a couple of the examples and clarify some things. So the first thing we talked about when solving equations is what does an equal sign actually mean? A lot of times we just think that's the answer, so like when I see the equal sign, whatever comes after it is the answer. But really, all an equal sign means is the expression on either side of the equal sign has the same value. So whatever's to the left of the equal sign has to have the same numerical value as whatever's on the right side of the equal sign. So we can think of an equation like a scale or a balance, like this kind of balance, where both sides have to be exactly the same. So whatever numbers and symbols and stuff I have over here has to be exactly the same as whatever's over there. So when we solve an equation, we're finding the value of x that makes the equation true. So if I took a simple example, say x plus 2 equals 6, okay, I can figure out that in order for this equation to be true, x would have to be 4, because 4 plus 2 is equal to 6, and that's the only number that I can add to 2 and have it be equal to 6. So when I solve for x and I find that x is equal to 4, I'm finding the value of x that makes the equation true, because we said it has to be balanced. So if this side is equal to 6, then this side has to be equal to 6. So when we solve equations, what we're really doing is working backwards. And a lot of times we get confused. We know that we're trying to get x by itself. We know we have to use inverse operations to get things to the other side, but we're not sure where to start. Okay, so remember that we're working backwards. So in the last unit, we plugged numbers in for variables and then simplified. So let's look at what that would look like. If I had some number to plug in for x and I was going to simplify this expression. Following order of operations, the first thing that I would have to do to the x is multiply by 5. So I'm going to write that over here, multiply by 5. That would be my first step if I were working forward. So this is going forwards. Okay. I would multiply by 5, then I would subtract 4, and then the last thing that I would do is divide by 7. Again, that's if I were going forward. So if I plug some number in for x, I would multiply that number by 5, then I would subtract 4, then I would divide by 7. So when we solve equations, we're going to start from the bottom and we're going to work backwards and do the opposite. So going forward, the last thing I did was divide by 7. Going backwards, the first thing I'm going to do is multiply by 7. And remember, I have to do it on both sides because an equal sign is like a balance. So if I do something to one side, I have to do the same thing to the other side to keep the scale in balance. On the left side, 7 times 8 is 56. On the right side, remember we said that the 7s cancel each other out, but it's not like it just magically disappears. It's because 7 divided by 7 is 1. All right, and anything divided by 1 is just that number, so I don't need to write it anymore. That's how it disappears. So I have 5x minus 4 on this side, so I took care of that step. Over here, my next step would have been subtract 4, so I'm going to do the opposite and add 4. Again, to both sides. So now I have 60 is equal to 5x. And again, same thing here. These, we say they cancel out or disappear, but why do they do that? Negative 4 plus 4 is 0, so I really have plus 0 here. Okay, but anything plus 0 is still that number, it doesn't change, so I don't have to write the plus 0. That's how it disappears. So I did my subtract. Last step this way would be multiply by 5, so I'm going to divide by 5 because we're always doing the opposite. 60 divided by 12, or 60 divided by 5 is 12, so 12 is equal to x. Okay. Remember we said that you should never get a solving equations problem wrong because you can always check your answer, and I can check it by using substitution. So I'm going to take this answer that I got, x equals 12, and I'm going to plug it into the original equation. So here it is originally, 8 equals 5x minus 4 divided by 7, and I think that x is equal to 12, so I'm going to substitute a 12 in there for x. All right, and then simplify. So 5 times 12 is 60. 60 minus 4 is 56. and 56 divided by 7 is 8. I got a true statement, 8 equals 8. That means this answer is correct. All right, then we had a lot more examples. I'm going to do number 2. And remember, I'm going to do this one because we said there's 2 different ways to solve it. So the first way I can solve this is using my work backwards theme. So if I started with x, the first thing I would do is add 3, and then I would multiply by 5. So I'm going to go backwards. I'm going to divide by 5 to start. Okay, so now I have x plus 3 equals 7. Then I'm going to do the opposite of plus 3, which is minus 3, and I get x equals 4. Some of you might be more comfortable solving this using the distributive property, so I'm going to write that over here and do this problem using the distributive property. Okay, so the first thing I would do is multiply 5 times x and then 5 times 3. Okay, now we have a little 2-step equation. Same thing, I'm going to work backwards, so plus 15, I'm going to do minus 15. 5x equals 20, and then divide by 5. And x equals 4. So we get the same answer, either method you choose, whatever is going to be easiest for you to remember and do correctly. All right, I'm not going to go through all of these examples because we did them in class. If you were absent, you should complete all of these examples on your own and then check with me or a classmate to see that you got the answers correct and are doing them right. I'm going to skip ahead to our second set of examples. Sometimes we have to simplify before you can solve. So like if I look at this example right here, it's different than the ones that we've been doing because I have 2 different terms with a variable in that. We haven't had that before. All right, but we learned in our last unit that if I have like terms, so I have the same variable and the same exponent, that I can just combine them. I can put them together. So I have 15 is equal to 2x plus 3 more x's will give me 5x minus 5. All right, and now this is an equation that we should be able to solve. Working backwards, I'm going to add 5. I have 20 is equal to 5x, and then I'm going to divide by 5. And I get x equals 4. Okay, sometimes we have to use a distributive property to simplify. So here I'm going to distribute the 4, so I have 8x plus 12 plus 3x equals 45. And I'm still not done simplifying because look here, I have like terms. So 8x plus 3x gives me 11x plus 12 equals 45. And now from there, I can work backwards to solve. So minus 12, 11x equals 33, and then I divide by 11. So x equals 3. So now we have the same thing, all kinds of examples. I'm going to do 2 of them with you. I'm going to do number 1 and number 3 with you, and then you're going to be responsible for the rest. And again, check your answers with me or a classmate. Okay, on this problem right here, now I have 2 terms with a variable, but look, they're on opposite side of the equal sign. So before we can do anything else, I need to get them all on the same side. Now, it doesn't matter if you want to put the 3k over there or move the 5k over to this side. You'll get the same answer either way, so just whatever you want to do. I'm going to move the 3k, and to move it, I'm going to do the opposite. So I have 3k, so I'm going to actually subtract 3k from both sides. So over here, I have 2 plus 2k, and over here, I have negative 6. Okay, make sure that minus sign comes down with you. And now this is a problem that we've seen the same type and we can solve. So I can subtract 2. 2k equals negative 8. Divide by 2. K equals negative 4. Right, we're also going to look at, sorry, I'm going to do number 6 instead of number 3. So if you look at this, it looks kind of complicated, right? I have 1 fraction on the left side and 1 fraction on the right side. You actually learned this when you did proportions. If I have 1 fraction equal to 1 fraction, I can solve this by cross multiplying. Okay, so I'm going to multiply 2 times b minus 4. So I have 2 times b minus 4, and I need to put this in parentheses because it goes together. All right, I got to multiply 2 by everything that's on the top here. And then I'm going to multiply 6 times b. All right, now this is a problem, a type of problem that we've seen. You can solve this, you can work backwards and divide by 2, or we can use the distributive property, whatever you want to do to solve that. And you should end up with -2 there. So again, you got the rest of those examples on your own. Check your answers with me or with a classmate. I'd be happy to explain anything that you do not understand. All right, and the last thing we're going to look at is special solutions. So sometimes when you are solving, the variables will cancel each other out. They'll be equal to 0 and they'll disappear. And then all we're left with is numbers. That is a special situation, okay? If you are left with a true equation, so your variables are gone and you have something like 4 equals 4, all right? We call that infinite solution. So remember we said when I'm solving, I'm finding the value of x that makes the equation true. If you end up with something like this, it means it doesn't matter what number you put in for x. Every single number will make that a true equation. So we say there are infinite solutions. If you end up with two different numbers, so you have something like 3 equals 4, well, that's not true. Okay, so that equation has no solution. There's no possible number for x that we could put in to make that equation true. So let's look at a couple examples and see what that looks like. Okay, so I'm going to start simplifying. The left side is simplified already. On the right side, I have to distribute, so my left side stays the same. Here I have 15x minus 12 minus 10x. And now I have like terms here that I need to combine, okay? So 15 minus 10 is 5, so 5x minus 12. Now I have variables on both sides, so I'm going to move one of them over, okay? And when I do that, all right, on this side, 5x minus 5x is 0x, so there's no more x's left. I just have 5. On this side, 5x minus 5x is 0x, and all I'm left with is negative 12. Now, 5 does not equal negative 12. That's not true, so there is no solution. All right, so in my original equation, there's no possible number that I could plug in for x and make this true, make both sides have the same value, so there's no solution. In this example, all right, same thing. I got to distribute first, so I have 6b minus 3 minus 7 equals 6b minus 10. I have like terms here with my numbers. Remember, constants are also like terms. So negative 3 minus 7 is negative 10. Okay, now I'm simplified. I can move to the other side. So I'm going to subtract 6b from both sides. All right, and again, 6b minus 6b is 0b. So I have negative 10. 0b, negative 10. Now, negative 10 is equal to negative 10. That is true. So I say I have infinite solutions. All right, no matter what number I plug in for x or for b, I can put anything, negative 4 or 270 million, and it's always going to be true. So there are infinite solutions. All right, couple more examples here, but again, I'm going to have you complete those on your own. I have answers for you to check. Your classmates should have the answers. Okay, make sure that you're doing them correctly, and that is it for section 2.1.